In this chapter, the focus is on visual imagery. As you can see from our chapter outline, we'll be covering some very interesting issues related to visual imagery, many of which will be applicable to things that we experience in everyday life. As always, we're going to focus on a couple of main points in this chapter, and those are issues that we will cover in our multimedia activities for the module, as well as our critical thinking discussion. Most specifically, we're going to focus on imagery and perception and talk in some detail about whether they share the same mechanisms. And then we will jump down to an interesting topic and one that we can apply to our everyday lives, and that is how to improve memory using what we know about visual imagery. So let's get started and talk about, first of all, what is imagery? There are two different types of imagery. One is called visual imagery, and this is seeing in the absence of a visual stimulus. So imagine seeing something in your mind that is not physically present. So imagine seeing a picture of something in your mind. That's what is meant by visual imagery. Mental imagery is experiencing a sensory impression in the absence of any sensory input. How many times do you hear a song in your head? It's not actually playing, your ears are not actually hearing it, but you can certainly hear it in your head. That is what is referred to as mental imagery. Let's talk about imagery and perception and whether or not they share the same cognitive mechanisms. There is a spatial correspondence between imagery and perception, and it turns out that imagery and perception do share the same properties. For example, think about mental scanning. This is when participants create mental images in their mind and then scan them. One of the researchers who has looked at mental scanning a lot, and in fact the book mentions enough to fill 3 books, is Coslin. And he used this image right here in a series of studies, and what he asked participants to do was to memorize a picture, and the picture might look something like this. And so in this study he asked participants to memorize this picture and to create in their head an image of it. In their head, right, they are asked to move from one part of the picture to another, right? So let me just back up here and show you what that means. So they might be asked to move in their head from the motor to the anchor. All right, and so that I don't have to go back to this picture, notice that there's something in the way here. There's a cabin that's in the way. All right, but just imagine again that they're asked to move from in their head the motor to the anchor. All right. It turns out that it took participants longer to move longer distances than shorter distances. Now keep in mind that they are doing this scanning in their head. And so it took them longer, for example, to move from the motor to the anchor than it did from the cabin to the anchor. What he reasoned was that, like perception, imagery is spatial. And we learned about spatial issues when we talked about perception. Imagery, which again is just in our head, is the same way. And he argued that we can be distracted as we move from one part to another. And so in that picture that we saw, we could be distracted as we move from the motor to the anchor. We can be distracted by that cabin. Consistent with Coslin's research, Lee suggests that the distractions when scanning longer distances may have increased reaction times. Interesting things that we encounter during these mental scans, such as this cabin, are responsible for these distractions that create a longer reaction time. So if we're asked to scan from the motor to the anchor, if there is something in the way that's distracting us, like a cabin, that will lead to longer reaction times. All of this suggests that imagery and perception share the same mechanisms because they both act exactly the same. So it doesn't matter if we are scanning an actual physical image or if we are scanning a mental image, we still have those distractions that create a longer reaction time. Let's move on and talk about comparing imagery and perception. There has been some research looking at the relationship between viewing distance, and what I mean by that is viewing from afar, right? So in this image, we are viewing this car from afar. In this image, we are viewing this car much closer. In some of these experiments, we are asked to imagine a small object, such as this small car, next to a large object. Not surprisingly, we are quicker to detect the details of the larger object because this larger object fills most of our visual field because it is a larger object. In research about this, Coslin again asked participants to do something that he called a mental walk task. In a mental walk task, participants are asked to imagine moving closer to a small animal than to a large animal. Now again, they are asked to do this in their head. They are asked to imagine a small animal and asked to imagine a larger animal. It turns out that participants had to, in their head, move closer for small animals than for large ones, right? And this suggests that images are spatial just like perception. And so if we were doing this for real, if there was actually a small animal and actually a larger animal, in order to perceive that small animal, we would have to physically move closer to it. It turns out that when we are asked to do this same task in our head, we have to move closer to it in order to perceive the details. So again, to summarize, this all suggests that imagery, which is in our head, and perception, which is actual physical stimuli, possess some of the same exact mechanisms. Okay, so how can we use this information? This is very interesting information, but how can we apply this? Well, let's talk about using imagery to improve memory. In other words, how can we use this mental imagery to help improve our memory, which we know is very fallible? One technique is called placing images at locations. And this is just what it sounds like. You imagine objects in a physical space. And we've all done this when we're trying to remember where that book is. We can, in our head, we can see it sitting on our coffee table in our living room. Or if we're trying to find that pair of gloves, right? We can see that pair of gloves in a basket in our hall closet. This is referred to as the method of loci. This is when we visualize objects to be remembered in different locations in a mental image of a spatial layout. So one thing that we can do to help us to remember things is to try to visualize them in some location in some spatial layout. So we imagine that book is sitting on the coffee table. We imagine that those gloves are sitting in a basket in our closet. Another method to improve memory using imagery is to associate images with certain words. This is referred to as the peg word technique. And what we do here is that we associate items to be remembered with concrete words. And then we pair each of these words with a peg word. So let's imagine that we are trying to remember bun, shoe, and tree. And these are examples that were used in the textbook. And so we might pair each of those words with a peg word. For example, 1, bun, 2, shoe, 3, tree. The idea here is that by pairing each of these words with a peg word, and the most important step, creating this vivid image, it turns out that we are better able to represent that word in our memory, which makes it more likely that we will recall what those words are. So we have two techniques now: placing images at locations and associating images with words. Again, what these techniques share is the use of visual imagery, and it turns out that both of these techniques work pretty well at improving our memory.